Hi Trig girls, this is the video for your in-class work on Monday. So I want to give you a little bit of information about what's coming up in Trig so you know what to prepare for, so you know what this week and next week will look like. Today you're going to have a video lesson that covers an extension from 13.4, which is a unit we just had a quiz on, but it delves a little bit more into what we can do with our calculator to find specific angles. So we'll see that information today. Then tomorrow, we're just going to have a practice day with that same content, and I'll post the solutions for you to practice as you go along. Then, on Wednesday, I'll come back, and we'll take a look at one more piece of this inverse trigonometric work and how we can put together different pieces of information from trig functions, kind of like a puzzle to get new values out. On Thursday, we'll do our last topic that pertains to the content from Chapter 13. And it's going to go a little bit beyond what's covered in our textbook and get very briefly into some physics applications of trig. So how we can talk about how quickly things move based off of the angular distance that they cover. So that's what we'll see this week. Then on Friday, we'll begin to review and practice. So this upcoming Friday, we're going to take a look at all of our triangle trig. So that's going to be 13.1, 13.5, and 13.6. So that's what your first quiz was on. Then I'll give you a practice assignment that you'd want to have for Monday, and that will cover some of that content as well, and also a little bit of the material you just saw on your quiz last Friday. On Tuesday, we'll have another Chapter 13 review, and then Wednesday will be our first longer assessment, and this will cover all of the Chapter 13 content, so everything we would have done to date. Now this assignment I'm going to put in ACT style format just so that you can keep practicing and feel comfortable that when you have those ACTs and a few more opportunities before December, that you really feel comfortable with the way the questions look. And that's also going to practice and help you with college math placement exams as well. We'll also work in one additional day on Thursday to talk about ACT questions covering material you've seen up to this point, just so that way we're really retaining our algebra and geometry skills as well. So today we're going to talk about that extension of inverse trig operations, and again this is going to be very heavily calculator based, so you want to make sure you have that calculator all set to go. These notes are going to be on the website, so if you wanted to print them off or to have an electronic copy, you can just download that PDF under Monday. So today we're going to get into how we evaluate angles given an inverse trigonometric function, and specifically doing so with our calculator. But before we do that, one thing that we really need to think about is for each of the types of trigonometric functions we work with, and specifically our values of sine, cosine, and tangent, we want to know in which quadrant or where on the unit circle is each one positive and each one negative. So an easy way to think through that is if I look in quadrant 1 up here in the top right, notice all of my y values are positive. So if all of my y values are positive, that means all of my sine terms are positive. All of my x terms are also positive. So that means all of my cosine terms are positive. Now, tangent is equal to sine divided by cosine. So if I divide these two terms, I'm also going to get a positive term. So in the first quadrant, all three of our essential trigonometric functions are positive. Then, if we come over into quadrant 2, we just want to compare those same things. If I look at my y values here, they are all going to be positive. So all of my sine terms are positive. If I look at my cosine terms, notice all of the x values have a negative sign here. So all of my terms are negative here. Then, because tangent is sine over cosine, since those are opposite signs, all of the tangents in this quadrant are negative. Then we come down to quadrant 3. Here, all of my x terms are negative, all of my y terms are negative. So that means my sine is going to be negative, my cosine is going to be negative, and then my tangent value, well, that's going to be positive because I have a negative divided by a negative. Last up over here in quadrant 4, same kind of analysis. I take a look at my y terms. They're all negative. take a look at my cosine terms, my x terms, they're all positive. And then my tangent, opposite signs divided means my tangent's going to be negative. So there is an easy trick to remember in which quadrant, which of the trig functions is positive. There's a nice little mnemonic device for that, and it goes like this. All, so I start in my top right quadrant, all, and then students. In my second quadrant, take calculus, which is my hope for all of my math students. But what this is actually telling us is in the first quadrant, everything's positive. In the second quadrant, S, sine, is positive. In the third quadrant, T, tangent, is positive. In the fourth quadrant, C, cosine, is positive. So if you use that phrase, all students take calculus, it tells you all, sine, tangent, cosine, those are the positive values in those quadrants. So we're going to be using this information for all of the calculations that we do. So you probably want to sketch a basic circle or a circle reference frame out and make sure that that's labeled, that you know which central trig function is going to be positive in which quadrant, because that will play a key role in our calculations. So let's go ahead and take a look at our first problem, and we'll keep that for reference as we go along. Here, this is our first example problem involving inverses. So this says, given that 0 is less than or equal to x, which is less than 360, identify where the sine of x is equal to 0.59. So when you read these kinds of problems, this information is not anything that is involved in the actual calculation. What this is telling you is that you're within one time around the circle. So remember, there is an infinite number of possibilities for circular work because you can continue going in circles forever. So this tells you you're just in one circle. So that means I can start here at 0 and I can go around one time, and I'm reporting those values, but that's it. The other thing that it tells me is your values need to be between 0 and 360 degrees. So that means I need to report my answer back in degrees. So it tells me the sine of x is equal to 0.59. So if I'm given that kind of information, to actually find the angle x, I'm going to take the inverse value. So I take the inverse of 0.59, and I just go to my calculator to do that. Now here, I need to make sure I'm in degrees because I'm being asked to work in degrees. So I say the inverse sine of 0.59, and I get out the value of 36 point, and let's round to 2 decimal places, so 36.16. So I've got 36.16 degrees. Now, if I think about my circular reference frame, that means I'm over here in quadrant 1. So I have my initial side at 0, and then I've gone 36.16 degrees. However, one of the key pieces of information that we need to know is that when we're working with inverse sines or inverse cosines or any kind of inverse trigonometric function, and we're going around the circle one time, we are going to have 2 solutions. That's going to be true for every single value that is not one of our quadrant values. So if we think about this with what we've done in the unit circle, notice over here, if I take the sine of 30 degrees, I get root 3 over 2. I get 1/2 if I'm taking the sine. Notice there's another place where the sine is 1/2, over here at 150. So anytime I'm trying to find an inverse operation, I'm always going to have 2 angles that have that same sine or cosine or tangent. The only place where that's not going to be the case is at our 0, 90, 180, and 270, because those are our special cases. Every place else I am on a circular reference frame, there are going to be 2 angles that have that same sine, cosine, or tangent. So in order to figure out where that other angle is, I just need to think about where my trigonometric functions are going to be positive or negative. So here, my sine is positive, so I need to find the other places where sine's going to be positive. Here, all are positive. Here, sine's positive. Here's where tangent's positive, and here's where cosine's positive. So to find the second angle whose sine value will be 0.59, what I need to do is work with reference angles. So over here, my sine is positive. This value right here is 180 degrees. So that means if I subtract 36.16 from 180, I'm going to end up with another value